Hi everyone, in Algebra 3 today we're going to be going over your new material from lesson 68, which is on the locus definition of a parabola, translated parabolas, and then applications and derivations. So we are going to be going over a new equation for parabolas that we're going to be evaluating for it, graphing, and then shifting it around. We're going to be adding some new things in too. So for this lesson, locus definition of a parabola is the locus of all points that are equidistant from a given point called the focus. So if this is my parabola, what that's saying is that the distance between the parabola and the focus is going to be equal distances away in every point from this point to the parabola as the directrix is. And the directrix is going to be a given line right here, a given line that's equal distances away from the parabola to the focus and the directrix. So this distance is the same as this distance. And you could also create any unique line from the focus to any point on the parabola to the directrix. So you should be able to see that this distance is going to be the same every time from the directrix to a point on the parabola and the focus to the point on the parabola. There are going to be a lot of little formulas that you do need to memorize on this, so make sure that you are taking notes on this lesson. So the equation that you're going to be looking at is going to be y is equal to a times x minus h squared plus k. Now our a is going to be 1 over 4p. That's going to determine how narrow or how wide your parabola is going to be. X minus h is going to be your axis of symmetry. So again, you would set that equal to 0, and that would be your axis of symmetry. Your vertex is going to be at this point at h comma k, and your focus is going to be at h comma k plus p. So wherever h is, it's going to be directly above that, your vertex, or directly below it. And then your directrix is going to be an equation of a line. So this is a line. That's why it's y is equal to k minus p. So these are all things that you have to memorize. So it's a normal parabola shifted h units horizontally and then k units vertically. Okay, so what we're going to be given is we're going to do some of these examples together. It says a parabola has a vertex at -2, 1 and a focus at -2, -1. Write the equation of the parabola, the directrix, the axis of symmetry, and then sketch the parabola. So what I'm going to do here is we're going to use some of those variables that they give us. So it says the vertex is going to be at h comma k. So first of all, so this is an example, the vertex that they give us is -2, 1. But our vertex, I know the variables are h comma k. So if I match that up, I know that my variable h is going to be equal to -2. I know that my k is going to be equal to 1. Now what I'm going to do is I'm going to go to the focus. Now for my focus, I have -2, comma, -1. Well, for the focus, the variables are h, comma, k plus p. So I already know that my h is equal to -2. I've already said that. But k plus p is going to be equal to -1. So k plus p is equal to -1. Well, I already know that k is equal to 1. So I'm going to plug that into my equation here. 1 plus p is equal to -1, which means that p is going to be equal to -2. So these variables right here are all going to help me solve for my equation of my parabola. The equation of the parabola goes like as stated, the equation written out, and you can write this down, y is equal to 1 over 4p times x minus h squared plus k. So I already know h, k, and p, and that's all I need to know to solve for the equation of the parabola. So y is going to be equal to 1 over 4 times -2 times x minus -2 squared plus k, which is 1. So I replace my p with -2, my h with -2, and my k with 1. And now I just need to simplify that. So y is going to be equal to -1/8 x plus 2 squared, and then plus 1. Okay, so that's my first equation. Now I need to find what the directrix is. So the directrix is going to be an equation of the line, and it's going to be y is equal to k minus p. Well, I know what my k is equal to. My k is equal to 1, and my p is equal to -2. So 1 minus -2 would turn into y is equal to 3, and that would be my equation of my directrix. And then my axis of symmetry is last, so axis of symmetry you can actually just get from your equation, because remember you just set this x plus 2 equal to 0, which gives me an axis of symmetry is at x is equal to -2. So far I have 3 answers. I have my equation of the parabola, I have my equation of the directrix, and I have my axis of symmetry. Now I need to sketch the parabola. This negative sign tells me that it's going to be a sad face parabola, so it's going to open down. And then I'm just going to plug in what I am given. And this doesn't have to be perfect. I'm not looking for a perfect parabola by any means. So I'm going to draw my thing. So this would be 1, 2. Okay, so it says my vertex is at, well, axis of symmetry is at -2. So I'm going to put in my dotted line at -2. My vertex is at -2, 1. So this is my vertex. My directrix is at y is equal to 3. So go up 3. And it's going to be a horizontal line through y is equal to 3. So that is your directrix. And then your focus is at -2, -1. So -2 down 1, this is your focus. And I know that my parabola is going to go away from the directrix. It's never going to intersect the directrix. So you're just going to sketch a parabola that is going to open down like that. Now again, I'm not looking for a perfect parabola, so I'm not looking for a narrow, wide parabola. All I'm looking for is that you put in your directrix, which is a line, a horizontal line, your axis of symmetry, which is always a vertical line, your vertex, and your focus all to be labeled, and then as well as having your equation, your directrix, and your axis of symmetry. So I know it's a long problem, but with some practice, it gets pretty repetitive. So just make sure that you're memorizing all the things that you're given, what your vertex, focus, and then directrix, and all of those things are. So moving on, we are going to now look at your lesson. So for lesson 68, we're going to start on number 9. We're going to do some additional problems as well. So make sure you are watching this entire video. Also a reminder that your test is going to be tomorrow. Part 1 of your test will be tomorrow. Part 2 will be on Thursday. So please make sure you're checking RenWeb. So number 8, it says a parabola has y equals -3 for its directrix, and its focus is at 0, 3. Find the coordinates of the vertex and write the equation of the parabola. Okay, so they give us that the directrix is at y is equal to -3. Well, they give it, I know that my equation for directrix is y is equal to k minus p. So that doesn't give me a whole lot of information. So basically I know that k minus p is going to be equal to -3. Then they tell me that the focus is at 0, 3. Well, my equation for focus is h comma k plus p, which means that my h is going to be equal to 0 if I match it, and my k plus p is going to be equal to positive 3. Well, if I have these two equations, k minus p is equal to negative 3 and k plus p is equal to 3, I could actually do elimination there. That would give me, the p's would cancel, and I would have 2k is equal to 0. So therefore, k is going to be equal to 0. Now, if k is equal to 0, then my p is going to be equal to 3. So all of these things here are kind of my chart for how I'm going to solve for the vertex, the coordinate of the vertex, and the equation of the parabola. So for the vertex, the variables that they give, I know, are h comma k. Well, what are my h and my k? My h is 0 and my k is 0, so that means my vertex is going to be at 0, 0. It's one of my answers. Then it says to find the equation of the parabola. So the equation of the parabola needs to be memorized as well. Y is equal to 1 over 4p x minus h squared plus k. So my p is going to be 3, my h is 0, my k is 0. So when I plug that in, be 1 over 4 times 3 x minus 0 squared plus 0. And that would give me an equation of 1 over 12 x squared. So I didn't say that you had to sketch, or I didn't type out that you had to sketch this problem, but I think you probably need to. So we're going to go through and we're going to graph our parabola. So this right here is positive, so I know it's going to open up. And we have an axis of symmetry at 0, so so my axis of symmetry is actually equal to 0. So this right here is going to be my axis of symmetry right there. Sorry, axis of symmetry. My vertex is at 0, 0, so I would just say this is my vertex. My focus is at 0, 3, so up 3, this is my focus. And my directrix is at y is equal to negative 3, so 1, 2, 3 down. And again, that is a line, a horizontal line through negative 3. And then because it's opening away from the directrix, this is my directrix. I'm going to draw a parabola that opens away from the directrix. And that concludes that problem. So again, a lot of steps. It's kind of a time-consuming problem, but again, just follow all of those steps. Okay, so moving on, we're going to look at number 9 as well. So for number 9, we're going to actually start with trying to graph this. So it says that the focus is going to be at 0, 3. 1, 2, 3. This is my focus. And then my vertex is 0, 1. This is my vertex. Okay, so if this is the case, I said that the distance between the vertex and the focus is the same as the distance from the vertex to the directrix. So if the vertex and the focus, it goes 2 spaces away, 1, 2, that means the directrix will be 2 spaces in the opposite direction. So 1, 2, and that would be at So again, 2 spaces between the vertex and the focus, then the vertex and the directrix. So this is my directrix, And that equation, you don't even have to use the formula, is going to be y is equal to -1. We also know the axis of symmetry because remember the vertex and the focus are always on the axis of symmetry. So that means the axis of symmetry is going to be at x is equal to 0. So this right here is going to be my axis of symmetry. We also know that this parabola is going to open up because it's going to go away from the directrix or towards the focus. So that would be your sketch of your diagram or your sketch of your parabola. All I'm left with now is I have to find the equation of the parabola. So I do have to kind of work backwards now. So for my focus, let's just start here. So focus, I am given 0, 3. And for the focus, the equation is h, k plus p. So that means my h is 0. And my k plus p is going to be equal to 3. Now for my vertex, it's 0, 1, and that equation is h, k. So that means I already know my h is 0, but now I know my k is 1. And if my k plus p is equal to 3, well, 1 plus p equals 3. That means my p is going to be equal to 2. So these are your variables that you're going to use to solve for the equation of the parabola. And that equation is going to be y is equal to 1 over 4p times x minus h squared plus k. So now you just plug in your variables. So I have 1 over 4 times 2 times x minus 0 squared plus 1. So 1 over 4 times 2 is 8, x squared plus 1. And that concludes how you would do number 9. So it was a little bit of a different process that I did. So I wanted to show you a different way that you could actually do the same thing that we did before instead of, this one has a lot, I think, less memorization. So it also explains the concepts a little better because you know where the directrix is going to be without having to use an equation. You would just go based off of the diagram. So either way works, but I think sometimes doing it this way is a little bit quicker. So moving on, we're going to look at number 10. So for number 10, it's a word problem, and I don't think you see another one of these ever. So the reflecting surface of a parabolic antenna has a shape formed from when the parabola y equals 1 over 100 x squared is rotated about the axis of symmetry. If the measurements are in feet, how far from the vertex should the receiver be placed if it is to be placed at the focus? So what we're looking for is the focus. Using the equation y equals 1 over 100 x squared plus essentially 0. You know that using the equation that we're given of a parabola, y equals 1 over 4p times x minus h squared plus k. Based off of this equation, that h is equal to 0. And k is also equal to 0. Which means that our vertex, h comma k, is actually at 0, 0. So our vertex is at the origin. And now what we're trying to do is we're trying to find the focus. So if I were to draw this diagram, I know that it's a positive parabola because it opens up because this is positive and it's starting at the origin. So it should look like this. And what we're trying to do is we're trying to find the distance here, the distance between the vertex and the focus. So this is the vertex, this is the focus. So we have to try to find this distance right here. So if I know that k is equal to 0, I need to solve for p. So remember, for the equation of a parabola, it's 1 over 4p. So that means that 1 over 4p is equal to what we're given at 1 over 100. So when you cross multiply that, you really get 4p is equal to 100, and therefore p is equal to 25. So the focus is always placed at h comma k plus p. Well, I already know what h is equal to. It's 0. K is equal to 0. So 0 plus 25 would mean 0 comma 25. So if my vertex is at 0 comma 0 and my focus is at 0 comma 25, how many spaces are between the vertex and the focus? Well, if it starts at 0 and then ends up at 25, I know that the distance is 25, and they give us that that's in feet. So that means that my receiver should be placed 25 feet away from the vertex. And that concludes number 10. So again, that's a word problem based off of this new lesson, but I can't recall how many times it shows up, but I don't think it's very much. So that's just another word problem for application. Now moving on to number 11. Number 11, it says the test scores were normally distributed with a mean of 78 and a standard deviation of 4. Approximately what percentage of scores lies between 74 and 82 and 78 and 82? Okay, so for this one, for number 11, I have 3 percentages that I know. I have 68%, 95%, and then 99%. 68% is always the mean plus or minus 1 times the standard deviation. 95% is always the mean plus or minus 2 times the standard deviation. And 99 is always the mean plus or minus 3 times the standard deviation. So basically what this means is if you have a normal curve that looks something like this, this is the mean. As it gets larger, it's going to encompass more and more of the population. So what we're going to do is we're going to start with if the mean is 78. So 78 plus or minus 1 times the standard deviation of 4. Well, 78 minus 4 would be 74. 78 plus 4 would be 82. So that means from the mean of 74 or 78, if I were to draw this, this would be 74 to 82. So that means that from 74 to 82, this would cover 68% of the population. So our answer for A, it says approximately what percentage scores lies between 74 and 82. Well, 74 to 82, that would be 68% of the population. Now for B, so that's A, that's the answer for A. For B, it says approximately what percentage scores lie between 78, which is our mean, and 82. Well, if you notice, that is actually just half of what our last percentage was. It's half from the mean to the highest point and then the mean to the lowest point. It's equal distances away. So that would be half of our original percentage, which means that B would be equal to 34%. Okay, and that concludes number 11. Number 12, on this lesson only, you actually can skip because I think it's one of those that you can't divide into 4 equal groups, so I'm not requiring you to do number 12. So number 12, you can skip. And if you're actually watching this video, you know that you can skip it now. Number 13, we are going to graph. So the first thing that I'm going to do is I'm going to convert this from logarithmic form to exponential form, making this x is equal to 3/2 to the power of y. So n equals b to the L. So this is my L, my exponent. This is my b, and this is my n. So now I'm going to make a chart. Instead of plugging in for x, I'm going to plug in for y. So I'm going to plug in -1, 0, and 1. Well, if I plug in -1 into this exponent, it just flips the base. So that becomes 2 over 3. Anything to the 0 power is 1, and then 3/2 to the power of 1 would just keep it the same at 3/2. So my diagram is going to look a little bit different. For the first one, I'm going to go over 2/3 and then down 1. For the second one, I'm going to go over 1 up 0. For the second one, I'm going to go over 1 and 1/2 up 1, which means that it's still an exponential diagram, but it's just going to be a little bit flatter than normal. So it should look something like that. Okay, now we're going to look at numbers 14 and 15. So for number 14, it asks us to write this as a cosine function. So number 14 is asked to write this as a cosine function. If you notice, this is actually already in a positive cosine function. So for number 14, the first thing that we're going to do is we're going to solve for a, which is going to be the midpoint between the top and the bottom number. And the top is 6 and the bottom is 0. So the midpoint between 6 and 0, 6 plus 0 divided by 2, would be 3. Then b is finding the distance between 6 and this middle number, which we just evaluated was 3. So you do top minus that middle number of 3, so we get an amplitude of 3. So here. This is in radians, so c is going to be 2 pi divided by the length of the period. So 2 pi. Notice that it's peaking at 0 and then it's peaking again at 2, which means the length of that period is going to be 2. So peaks at 0, then peaks again at 2. So that distance would be 2. And when you divide that, that just leaves us with pi. This is already a cosine function, so I don't actually need to change anything. There's no phase shift. So we're only going to use this equation right here. Y is equal to a, which is 3, plus b, which is 3, cosine c, which is pi, and that would just be theta. Because again, there's no phase shift because it's already a positive cosine function. It already peaks at the origin. Number 15, it looks like you need to make this into a sine function, which if you look at it, it already slopes down at the origin, through the origin, which means it's already a negative sine function. So we're going to use that second equation right there. I'm going to still solve for what a is equal to. So the midpoint between the top and the middle number, that's 4 and -2. So you add those together, divide by 2. That gives me a result of 1. B is the amplitude, so the distance between that top number and the number you just found, which means you do 4 minus that number, which is going to give me 3. Now for C, this is in degrees, so it's 360 divided by the length of the period. Now notice that this rotation at 0 degrees starts and then it circles down, circles up, and then ends at 100. That means that the period length is 100. So 0 circles down, circles up, ends at 100. So it's 360 divided by 100. And the zeros are going to cancel. So you could leave this as a fraction, and I think that's what they do in the book. So that would be 18 over 5. So your answer, again, it's a negative sine function, so you're going to use this equation. Y is equal to a, which is 1, minus b, which is 3, sine c, which is 18 over 5. And then there's no phase shift, so your answer would just be x. And that concludes number 15. Now I want to look at number 16 with you as well. So for number 16, we have multiply these two together, these two polar forms together, and write your answer in rectangular form. Well, when we multiply, remember you multiply the two outside numbers. So 3 times 5 gives me 15. And then you add the degrees together. So 310 plus 80 would be 380. 90. Well, 390 degrees is greater than 360, so I'm going to subtract 360 from that. And that gives me a degree of 30 degrees. When I expand CIS, I get 15 cosine of 30 plus I sine of 30. 30 degrees is a reference triangle in quadrant 1 with a 30-degree angle. The adjacent is √3. The opposite one is the hypotenuse is 2. So if I'm evaluating this right here, the cosine of 30 degrees is adjacent over hypotenuse. So that would be 15 times √3/2 plus I sine. So the sine is opposite over hypotenuse, which would be 1/2. Then your last thing to do would be to just distribute your 15. It won't simplify at all. So your result is just going to be 15√3/2 plus 15/2 I. Don't forget that I in that second term. And that concludes number 16. Now I want to look at number 17, just starting to get you ready for your test taking that you're going to be doing. So the first thing that you're going to do for number 17 is to put all the x's together and put all the y's together. And the whole numbers are already on the other side. So for 17, I'm going to do x squared plus 10x, and then y squared minus 2y. It's going to be equal to 1. Now I'm going to complete the square. So half the term attached to x is going to be 5. So that would be x plus 5 squared. When I square that, that would be plus 25. Now whatever I do to one side, I have to do to the other. So if I add 25 here, I have to add 25 here. Now for my y, half of -2 would be -1. -1 squared, I would add 1. So I'm going to add 1. Which means the right side, I get the square root of 27, which unfortunately does not come out evenly. So I have my center, the coordinate of the center of the circle is going to be at the opposite of +5, which is -5. Opposite of -1 is +1. So -5, 1. The radius is going to be equal to the square root of the right side, which is square root of 27. So now you have to draw this, which is going to be a very large circle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, so I'm gonna draw the center of the circle. So -5, 1, 2, 3, 4, 5, up 1. This is my center of my circle. My radius is the square root of 27, which is approximately equal to 5.2. So I'm gonna go a little further than 5 spaces away. So 1, 2, 3, 4, 5, and a little further would be here. Up 1, 2, 3, 4, 5, and up a little bit would be here, then down 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, and down a little bit. So here and here. So this would kind of be my circle, but mine looks kind of like a football instead, where my radius is equal to the square root of 27. Okay, and that concludes number 17. Then we're going to look at number 18 and we're going to look at number 19 because they go based off of each other. So for number 18, I need to solve for x. So the first thing that I'm going to do is I'm going to eliminate y, and I'm going to multiply the top equation by w and the bottom equation by d. So that would be 18 would be AWX minus DWY equals SW. Bottom would become B dx plus dwy equals dk. So when I add those together, the y's are going to cancel. And then you have AWX plus BDX equals SW plus DK. Have to factor out the x because that's what we're solving for. Oops. So that'd be AW plus BD equals SW plus DK. So therefore, x is going to be equal to SW plus DK over AW plus BD. And that's your result for number 18. But we actually need our result for number 18 to solve for number 19. So for number 19, it says use the result from 18 to solve for x. Well, what I need to do is I need to look at number 18 and number 19 next to each other so I can evaluate for what each letter is going to stand for. So if I look at the top equation, my coefficient for x is a on 18, and my coefficient for x on 19 is 3. So that means for this one, a is going to be equal to 3. This is number 19. Now my coefficient for y is negative d, and for 9 it's negative 5, which means that d is going to be equal to 5. So because they both have minus signs, that means d is going to be a positive value. Now it's set equal to s. This is set equal to 10, so s is equal to 10. For the bottom equation, the coefficient of x is b, and the coefficient of x is 4, so b is 4. Coefficient of y is w and 2, so w equals 2. And that's set equal to k, which is equal to 22. So that's how you match it. You just look at the coefficients of the previous problem, and match them with the coefficients of the next problem. And then all you have to do is plug those variables into what we got before. So x is going to be equal to s, which is 10, times w, which is 2, plus d, which is 5, times k, which is 22, over a, which is 3, times w, which is 2, plus b, which is 4, times d, which is 5. So now you're going to get 20 plus 110 over 6 plus 20. So 130 over 26. That does come out evenly, so x is equal to 5. So between 18 and 19, it's kind of just a matching game. And that concludes all the problems that I'm going to do with you for this lesson, lesson 68. Remember, you do have a test tomorrow. And in the comments of this video, please place all your questions that you have on lesson 67 by 9 a.m. on Wednesday. Hope you guys all have a great day. Bye.